Okay, guys, here's part 5 for the review packet for the Geometry Unit 7 test. So this first part's saying, let's just see if we can figure out what method to use if I don't tell you what method to use. So our options are trigonometry, which, if you want to think about it like this, is SOHCAHTOA. Our second option is the Pythagorean theorem, which is a squared plus b squared equals c squared. Then we have our 30, 60, 90 rules. Remember, the ratio between the short side to the medium side to the long side is 1 to root through to 2. And then the 45, 45, 90 triangle, all the sides have a ratio of 1 to 1 to root 2. 1 to 1 just means they're exactly the same. The two legs in a 45, 45, 90 are the same. Well, let's look at number 25. We see a 45-degree angle. Let's see if we can figure out which of these methods to use. Well, if I'm solving for two sides in a 45, 45, 90 triangle, then I'm going to use method D. Okay. Number 26. I'm looking at the problem, I'm solving for sides, but I see this 60-degree angle. That tells me, oop, I'm going to use my 30, 60, 90 rules. Okay. Let's look at 27. I have a side, and I'm solving for a side. As soon as you have two sides, you're solving for a third side. That's your Pythagorean theorem. Okay, I have two sides, but I'm not solving or needing my third side. I have an angle marked here, but it's not 30, 60, or 45. I need to solve for this angle. As soon as you have an angle that's part of your problem, we're never going to include that 90 degree because that's going to be a part of every right triangle. But if we have an additional angle, it's going to be trig if we don't have a 30, 60, or 45. So that's trig. Okay, so now what we're going to do is we're going to solve the triangle. What that means is to solve for all the missing side lengths and angle measures. So let's do number 29 together. We have this thing here. We have this thing here, but we don't have this side, we don't have this angle. So those are the three things that we're going to need to solve for. Let's solve for x first. Well, if I have two sides and I want to solve for a third side, I can use the Pythagorean theorem. Well, notice 15 is on the side by itself, or sorry, it's on, my bad, sorry, 15 is the hypotenuse, so when we use the Pythagorean theorem, it's going to be on the side by itself. 7 squared is 49. 15 squared is 225. I'm going to subtract 49 on both sides. And then I'm going to take the square root of both sides. And I get x equals 13.266. Well, let's take a look. We just solved for x. That's the side length for segment AC. So the length of segment AC is 13.266. Well, now let's see if we can solve for one of our angles. Let's solve for y first. For y, this is my, it's not a 30, 60, 90, and if I'm solving for an angle, my only other option is trig. So here's my opposite side, my adjacent side, here's my hypotenuse. I don't really want to use the decimal from x if I don't have to, and I have this side here length of 7 and this side a length of 15. So I'm going to use these two sides, which is a and h. That means I'm going to use cosine. So I'm going to say cosine of my angle y is equal to the length of the adjacent side over the length of the hypotenuse. And the way we get y is we use cosine inverse. And I'm going to kind of skip a step here. But if you look at the part 1, I go through a problem just like this. But remember, cosine inverse undoes cosine. So if I do it on this side, they'll cancel out. I get y. If I do it to this side, I'm left with it. So if I do cosine inverse of 7 over 15, I get a value of 62.182. Well, we were solving for y, the measure of angle B, so this is going to be 62.182. Well, I also need to solve for this angle here, and here's the important thing. Remember, this 90-degree angle plus the measure of angle y plus the measure of angle z, the three angles in a triangle have to add up to 180. So if I subtract 90 and then I take away the 62.182, I'm going to be left with 27.818. Okay? So that's how we do that problem. This problem is really similar. I want you to try doing it by yourself, but the key is on Blackboard so you can check your answers. I just won't have all the work. So let's keep going on. It says find the missing values in each. You may leave your answers a decimal or in simplest radical form. Let's see if we can figure out what method to use. Well, I see an angle that's going to be important. It's not 30, it's not 60, and it's not 45, so I must have to use trig. So here is my hypotenuse. Here's my adjacent side. That means I'm going to use cosine. So I'll let you finish this one by yourself. But we are going to use trig. So if that makes a difference, you can use that. Okay, number 32. I have a side, another side. I'm solving for a side. What am I going to use? Yep. A squared plus b squared equals c squared. Well, remember, c has to be the one on the, is the hypotenuse, the side opposite the right angle. So I'm going to end up with x squared plus root 6 squared equals the square root of 11 squared. So I get x squared plus 6. Remember, squaring and square rooting undo each other. I'm going to subtract 6 on both sides, and I'm going to get x equals the square root of 5. So you can leave your answer like this, or if you would rather leave your answer like this, you can. Again, remember, I round to the thousandths place, but your teacher might do something a little different. But if you're in my class, Mrs. Barnes' class, you need to round to the thousandths place. Okay, 33. I see an angle, but wait a minute, that's a 60-degree angle. That means I can use my 30, 60, 90 rule. So here's my short side, my medium side, and my long side. Now, you can use trig to solve this problem, and if you'd like to, you can. But I want to show you how to do a special right triangle, so I think we need practice. Okay, so where we have the small side, I can go to either direction. So from the small side, I can go to the long side, and from the small side, I can solve for the medium side. To get from small to medium, I take my value of my short side, and I have to multiply by root 3. When we multiply by a radical, we're going to multiply it with anything else under the radical. Oops, sorry, I'm turning my paper. 3 is the only thing on the outside, so it's going to be 3. 2 times 3 is 6, so 6 goes underneath. So the length of the medium side is 3 root 6. To get to the long side, I can multiply the short side by 2. So here's the, here's the short side. I multiply it by 2. 3 and 2 are outside the radical, so we multiply them together. 2 is inside, so we leave it just like that. So the length of the long side is going to be 6 root 2. Okay, I'm going to actually do this one really fast, just for those of you who might need a little more practice. So back to 31 really quickly. We already said this is going to be cosine equals a over h. Remember, when x is in the denominator, we multiply both sides by x, so x is no longer down there. X is multiplied by cosine of 34, so to get x by itself, we divide by cosine of 34. Remember, cosine of 34 is a number. It's like point something, something, something. It's a number, so we can divide by it. When I do that, I get x equals 17 over cosine of 34. And when I type that into my calculator, I get that x equals 20.506. And remember, a good way to check your answers is to say, wait a minute, this is my hypotenuse. This needs to be the longest side, and it is longer than the leg we were given, so that's a good sign. Okay, here is the next page. I'm going to finish topic 5 in this video, and then I'll do a separate video for the word problems. Okay, number 34. We need to solve for x. Notice that these two sides are marked with 1 tick mark. That means that they're exact same size. So that means I can write that this is going to be a length of 12. Well, now I have a side, and I'm solving for another side. This is going to be a Pythagorean theorem problem. Okay, let's look at number 35. Notice that these 3 angles are all marked with 1 arc. That means they're all the same. Well, if all 3 of them add up to 180 and they're all the same, what's y going to be? Yep, it's going to be 60 degrees, which means I have a 30, 60, 90 triangle. So here's my 60, here's my 30, which means this is my short side, my medium side, and my long side. To get from the medium side to the short side, because this is what I was given, I need to find a way to figure out this length. I have to divide by root 3. So when I do that, I get that my short side has a length of 5, but I want the whole bottom of the equilateral triangle, so that's going to give me a length of 10. Number 36, I'm solving for an angle. We don't know if it's 30, 60, or 45, so I can't use those rules. I don't know anything about this side, so it's definitely not the Pythagorean theorem, so I'm going to have to use trig. So I'm going to use SOHCAHTOA. So here's my adjacent side, here's my hypotenuse. So if I have a and h, that means I'm going to use cosine. Okay. Whenever I have to undo cosine because I have to get to that question mark inside. So I'm going to do cosine inverse to both sides. Remember, inverse operations undo each other. So cosine inverse and cosine undo each other. So when I do cosine inverse, I get 71.337. Okay, I'll let you guys do number 37 by yourself. Let's do number 38. I need to find a way to get from the fact that this is 9 to figuring out what this side length over here is. The only way I can do that is to find a way to get more information about this triangle. The only side that these two triangles share is this one right here, and I'm going to call this y. Because if I can solve for y using this triangle, I can then use y to solve for x using trigonometry. So let's do this one first. Here's my thing. This is going to be my opposite side. This is my adjacent side. So tan of 46 is O over A. I have to multiply both sides by 9. Make sure if you do it like this instead of the 9 at the front that you close the parentheses when you type it into your calculator. So I'll show you guys what I mean. Make sure when you do tan of 46, you close your parentheses or arrow out, depending on what kind of calculator you have, times 9. So I'm going to get a length of 9.3, and then it's 19. You can leave it as that, or if you were to round up correctly, it would be 3.20, but I know in class I didn't round up, I left it. So I'm going to leave it like this just so there's no confusion from class. Okay, so now I have this length of y. So now I'm going to solve for x, which is what I really want. So here's my angle. This is my adjacent side. This is my hypotenuse. So now I'm going to use cosine of my angle equals a, which was 3.19, which the y, right, over x, which is what I'm solving for. If you do the arithmetic, you're going to end up with x equals 9.319 over cosine of 58. This is way too big to write with. Which is going to give you a length of 17.586. So that's my value of x. I know it's a little hard to see, but it's 17.586. I have a green pen right here. I should have just used this all along. If you can't see it, now it should be easier to see. Okay, let's do 39 now. This is a 45, 45, 90 triangle. So that means, I should use this again. That means that these two sides are the same. So if this is 6, this is 6. To get to the hypotenuse on a 45, 45, 90 triangle, I multiply by root 2. So this side here is going to be 6 root 2. Well, now I have a 30, 60, 90 triangle, so here's my short side. This is my medium side. This is my long side. I have to find a way to get from short to medium. Well, I get to short to medium by multiplying by root 3. 6 is the only thing on the outside. I have 2 times 3 under the radical, so I'm going to get root 6, and that's my final answer for x. Okay, so here's I'm going to finish this video, and then I'll do a third video on part 6.